Good morning children, Sairam. Welcome back to another session of mathematics. We are in chapter 3, playing with numbers. This is part 10 of the chapter. In today's session, we are going to solve the problems of exercise 3.5. Please make sure that you have a pen and notebook to solve the problems. So what is question number 1 of exercise 3.5? Which of the following statements are true? So we have to look at the statement and understand whether it is true or false. Let's see how we do it. First one, A. If a number is divisible by 3, it must be divisible by 9. This statement is false. 6 is divisible by 3, but is it divisible by 9 also? No. So this statement is false. B. If a number is divisible by 9, it must be divisible by 3. Yes, it is true. Since 3 is a factor of 9, so if a number is divisible by 9, it must be divisible by 3 as well. So this statement is true. C. A number is divisible by 18 if it is divisible by both 3 and 6. Is it true? No, it is false. If a number is divisible by both 3 and 6, that doesn't mean that it is also divisible by 18. Let's see how. We can take an example. 30 is divisible by both 3 and 6. 3 10 times is 30 and 6 5 times is 30. But is it divisible by 18? No, it is not divisible by 18. D. If a number is divisible by 9 and 10 both, then it must be divisible by 90. True, because 90 is a product of 9 and 10, and we know 9 and 10 are co-prime numbers. So we have learnt in the divisibility rules that if a number is divisible by two co-prime numbers, then the product of the co-prime numbers will also divide the number. So if a number is divisible by both 9 and 10, then it is also divisible by their product 90. So this statement is true. E. If two numbers are co-primes, at least one of them must be prime. False. We have an example here. 15 and 32 both are co-prime numbers. But are they prime numbers? Is one of them prime number? No. Both of them are composite number. So it is not necessary that if two numbers are co-primes, one must be prime. No. If they have only one factor, that is 1 as a common factor, then they are co-primes. So this statement is false. F. All numbers which are divisible by 4 must also divisible by 8. This is also a false statement. We know that 12 is divisible by 4. But is it divisible by 8? No, it is not divisible by 8. So this is a false statement. G. All numbers which are divisible by 8 must also be divisible by 4. True, we have done this earlier. Any number, if it is divisible by a number, then its product, its factors also will be able to divide that number. So 2 and 4 both are factors of 8. So if a number is divisible by 8, then its factors 2 and 4 will also be able to divide the number. So this statement is true. H. If a number exactly divides two numbers separately, it must exactly divide their sum. True. We have learned this in the divisibility rules also. As 2 divides 4 and 8, it also divides their sum, that is 4 plus 8, 12. So this is a true statement. I. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. False. 2 divides 12, but does it divide the numbers which when added give 12? That means 7 and 5. Does it divide 7 and 5 separately? No. So this is a false statement. Now let's solve problem 2, question. So what is question 3? 2. Here are two different factor trees of 60 and we have to write the missing numbers. We have learned how to write how to do the prime factorization of numbers by factor tree method. So this is the same and we have to write the missing numbers. Let's see how we do it. A is 6 given as product of two numbers 6 and 10, and 6 can be split into two of its factors which are prime. So what are they? 2, and 2 multiplied by what gives 6? It is 3. So in the blank it should be 3. 2 3s are 6. And here we have 10 and we have to split into two of its factors, prime factors. So one is 5. What is the other one? We know 5 2 times is 10. So in this blank we will fill 2. So this is the answer. 6 is equal to 2 into 3. So we have filled 3 here, and since 10 is equal to 5 into 2, so we have filled 2 here. We have problem B here. The number is 60. So 60 is the product of which two numbers? It is a product of 30. 30 multiplied by what gives 60? 30. 2 times is 60. So we have to fill 2 here in the blank. And then 30, it has to be split into two of its factors. One is 10. What will be the other one? 10. 3 times gives 30. So we can fill 3 in this blank. And 10, the product of which two prime numbers gives 10? We know 5 multiplied by 2 is 10, or 2 multiplied by 5 is 10. So we can fill 5 and 2 in these two blanks. So the first blank we fill with the number 2, and here we have 3, and these two blanks we have 5 and 2. So we have problems 3 to 12 here. Let's see what is the third problem. Which factors are not included in the prime factorization of a composite number? So what are the numbers that are not included in the prime factorization? In the prime factorization of a composite number, 1 and the number itself, they are not included in the prime factorization of a composite number. And what is problem number 4? Write the greatest 4-digit number and express it in the terms of its prime factors. That means we have to write the greatest 4-digit number and do its prime factorization. Now which is the greatest 4-digit number? We know that 9999 is the greatest 4-digit number. Now how do we prime factorize it? We know we can get 9999 in the factor tree method. We do like this. We can multiply 9 and 1111 to get 9999. So these are the two factors, 9 and 1111. Then we have to further split them into their factors which are prime. So 9 can be split into two of its factors, 3 and 3, both of which are prime, and 1111 can be written as 11 into 101, and 11 and 101 both are prime numbers. So this is the prime factorization of the number 9999 by factor tree method. And what is the prime factorization? It is 3 into 3 into 11 into 101. Now let's see how we do this by division method. We will write the number 9999 and try to divide it with the smallest, beginning from the smallest prime number. So can it be divided by 2? No, we cannot divide it by 2. Now let's move on to the next prime number, that is 3. Yes, 9999 can be divided by 3, and what do we get here? We get 3333. Now again this can be divided by 3, and what do we get? We get 1111. 1111 can be divided by 11. 11 is a prime number and we get 101. And 101 is a prime number which can be divided by itself. So 101, 1 times is 101. So what is the prime factorization of 9999 by both the methods, by the factor T method as well as the division method? It is 3 into 3 into 11 into 101. Now let's move on to the next problem. Problem number 5. Write the smallest 5-digit number and express it in the form of its prime factors. That means we have to write the smallest 5-digit number and do its prime factorization. So what is the smallest 5-digit number? It is 10,000, isn't it? Now we can do its prime factorization first by division method. How do we do it? We will try to divide this with the smallest prime number, that is 2, and we know it is divisible by 2. So 2 divides 10,000 and we get, and what do we get? We get 5,000. Again 5,000 is divisible by 2, so we will proceed further with the prime number 2 only, and 2 divides 5,000 and we get 2,500. 2,500, again it is divisible by 2, and what do we get? We get 1,250, and it can further be divided by 2 and we get 625. Now 625 cannot be divided by 2. Let's move on to the next prime number 3. Can it be divided by 3? We can actually divide and find that it is not divisible by 3. Then we can see that it is also not divisible. Also not divisible by 4. Then we move on to the next prime number, that is 5. And yes, 625 can be divided by 5. And what is the quotient here? We get 125 as the quotient. Now 125, again it can be divided by 5 and we get 25, and we know 25 can be divided by 5 times 25, and we get 5 as the quotient, and in the last 5 can be divided by 5. 5 is a prime number and we get 1 here. So what is the prime factorization of 10,000? It is 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. Let's do this also by factor tree method. Yes, factorization by factor tree method. So how do we do this? We can take a different pair of the factors which give 10,000 on multiplying. So what are they? The pair of numbers that give 10,000 on multiplying is 4 and 2,500. Now 4 can be further split into its factors, which are prime numbers 2 and 2, and let's move on to 2,500 now. 2,500 can be expressed as 25 multiplied by 100, and 25 can be further split into 2 of its factors, 5 into 5, and 100 can be split as, it can be expressed as 20 into 5. Now 5 is a prime number, so we split 20 into its factors. So 4 into 5 is 20, 5 is again a prime number and 4 can be expressed as 2 into 2. So, in the end we have all the prime numbers. So, we will not proceed further and we will write the prime factorization of the number 10,000. So, what is it? 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. So, children, have you seen whether we do the prime factorization by factor tree method or by division method? We get the prime factorization as the same as the product. 10,000 will be the product of the same prime numbers. So, we have only one prime factorization of this number. So, what is question 6? Find all prime factors of 1729 and arrange them in ascending order. Now, state the relation, if any, between two consecutive prime factors. So, how do we solve this? First, let us find the prime factors of 1729 first. How do we do that? We do that by prime factorization of the number. So, we can see that 1729 is divisible by 7. So, 7 divides 1729 and gives the quotient as 247, and 247 is divisible by 13 and it gives 19 as the quotient. We know 19 is a prime number, so it will be divisible by 19. 19 one times 19. So, what is the prime factorization of 1729? It is 7 into 13 into 19. Now, let us see what is the relation between two consecutive prime numbers of this particular problem. So, we can see the two consecutive prime numbers here are 7 and 13, and what is the difference between 13 and 7? That is 6. And when we see further, then the difference between 19 and 13 is 6. So, the difference between the two consecutive prime numbers is 6. So, this is the relation between the two consecutive prime numbers here. Now, let us move on to the next problem. The product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. So, what does the statement say? It says the product of three consecutive numbers is always divisible by 6. You take whatever numbers, but the three consecutive numbers, and you find their product, it will always be divisible by 6. Let us understand this by taking this example. Let us take three consecutive numbers 2, 3 and 4, and what is their product? Their product is 24. 2 into 3 into 4 is 24. Now, we all know that 24 is divisible by 6. 6 4 times is 24. Let us look at the next example. Let us take three consecutive numbers 5, 6 and 7 and find their product. 5 into 6 into 7 is 210. Now, let us see whether this number is divisible by 6 or not. Yes, 6 divides 210 exactly, and we get 35 as the quotient. It is exactly divisible by 6, and since 0 is remainder, we can understand that this number is divisible by 6 completely. So, the product of three consecutive numbers is always divisible by 6. Problem 8. The sum of two consecutive odd numbers is divisible by 4, and verify this statement with the help of some examples. So what does the statement say? That two consecutive numbers, odd numbers, and their sum is the sum of two consecutive or odd numbers is divisible by 5. Let's understand this by taking an example. 5 and 3 are two consecutive odd numbers. If we add 3 and 5, we get 8, and 8 is divisible by 4. Similarly, if we take 7 and 9, which are two consecutive odd numbers, their sum is 16, and 16 is also divisible by 4. Let's understand one more example. We take two consecutive odd numbers 13 and 15 and add them. What do we get? We get 28, and 28 is also divisible by 4. So the sum of two consecutive odd numbers is always divisible by 4. Children, in this session we could complete up to problem 8 of exercise 3.5. Rest of the problems we will solve in the coming session, and then we will move on to the next topic. Till then, keep practicing whatever you have learnt in today's session.